Welcome to another fabulous recording of 7.1.3 What is the Relationship? Identifying and Describing Association. If you do not have paper and pencil in front of you yet, make sure to get some now. Please pause the video. If you have them, make sure to write these things at the top of your paper along with your name and class period. Once those are written, you're ready to proceed. So today we're going to be talking about when is it reasonable to make a prediction. So, for example, when you know the height of a tree, can you predict the size of its leaves? Or if you know the outdoor temperature for the day, can you predict the number of glasses of water you will drink during the day? In lesson 7.1.2, you found that some data sets were related and others were not. In this lesson, you will look at different situations and decide if they show relationships that allow you to make predictions. As you work with your teams today, use these focus questions to help you direct your discussion. When one value goes up, what happens to the other one? Is there a relationship between one thing changing and another thing changing? And can I make a prediction? So, how can two things be related? I want you to come up with your own example of two things that are related. Some things that we've seen so far in one problem, we saw that the higher the odometer reading, meaning the more number of miles a car has on it, the lower the price of the car would be. So, the odometer reading and the price of the car would be related. Hours spent on homework and the amount that a student understands the work come the time of a test. These are two things that could be related. Come up with your own example now of two different things that would be related. Okay, so now we're working on problem 7-23. Make sure to write 7-23 on your paper now. And it reads, the students in Mr. Carl's science class have been experimenting with different factors that they think may affect how tall a plant will grow. Each team planted seeds in several pots using different experimental conditions. With your team, read the questions that the students investigated. Write a team prediction, hypothesis for the results of each experiment. Assume that all the other variables are controlled, meaning that they will not affect the experimental outcome. Write your hypothesis so that it indicates a directional relationship between the independent and dependent variables. Does the amount of fertilizer affect the plant height? So, for each of these questions, as they pop up on your computer, I want everyone at the table to stop, share out their ideas, and then as a table, each of you should write in what your hypothesis was. Make sure to follow all of these directions. So the first one to have a hypothesis for is going to be, does how deep the seed is planted in each pot affect the height of the plant? So, do you think how deeply I put in a seed, is that going to affect how tall the plant will become? In what way? Is it going to be beneficial? Is it going to be hurtful? If I plant it deeper, does it grow taller? What do you think? What is your team's prediction? These are the things that you need to clearly spell out. Okay, now the next one. Once again, stop, discuss it as a team. Does the number of seeds in each pot affect the plant height? Does the size of the pot affect the plant height? Does the number of hours of sunlight per day affect the plant height? Make sure your answer to every single one of these questions is answered out in 7-23 on your paper. All right, 724, write it on your paper. After 3 weeks, the teams measured the heights of their plants and recorded their data. Team 1 data table and the question Team 1 investigated are included below. So we're given all of the information for Team 1. They had this question: does the amount of fertilizer affect the plant height? So what we're going to do, and what you should do, is every single table should get one piece of graph paper that you're all going to work on. Okay? On this one piece of graph paper that your entire table is doing together, you should clearly label your x's, mark the scale at equal intervals, title your graph appropriately, such as with the experimental question. So I want you guys to make a graph of the data below. Make sure to pause the video now, create this graph as a table. Okay, now I am going to show you a graph that I can create with the computer. I want you to pay attention to how I create this graph, because you will be using this same program to create the graph. The link to this program, GeoGebra, is in Google Classroom. Alright, so make sure you click on the link for this so that you can open up some of these pages. Alright, so first I'm going to input over here. So on the left, there's a place where I can click. I'm going to start my parentheses, and then I'm going to type in the numbers, 5, 14. So that's my first data. Press enter. Now I'll put in the next point, 10, 17. Now once again, you should have already have graphed this. I'm just showing you how to use this program. 15, 21. I start each of these by just pressing the parentheses button. And now we got 20, 31. Make sure you're typing all that out. Parentheses, 25, 33, enter. Parentheses, 30, 40, enter. Alright, so now that I've put all those things in, what we should be able to see is a graph. Now I don't see anything yet, and probably the reason is because all my y values are way up above where this is even showing. So you'll notice I've clicked on this tool that has the arrows pointing in each direction. It's at the top right of your screen. Once I've clicked on that, I can click on my axes, and it will then move my axes. And now I can see where some of my points have shown up. I'm going to do the same to x, because I can't quite see all of my x values either. And now that I've kind of adjusted it, I can now see all my points. Now you probably needed to do something similar with your graph paper in figuring out how you were going to number it. You'll notice that mine is counting by 2's for the x, 2, 4, 6, 8, 10. But in the y's, I had to count by 5, 10, 15, 20, 25. Now what you put on your paper might not look exactly like this. You may have counted by another number. What I am looking for is that every single one of the x's is counting by the same thing, 2, 4, 6, 8, 3, 6, 9, 12. The y's, maybe it's counting by a different number, but it's consistent, 5, 10, 15, 20. Now, I'm still missing a few things. What I'm missing are my labels. We need to say what this table was even all about. Now this one was about, so this was Team 1 does amount of fertilizer affect height. So that was their big question. Now, earlier when it said create a title, that's what a title is. All right, so this is just my title for the graph. The next thing I want to make sure to put in is I want to label my axes. So X is representing fertilizer. All right, so you guys can see I've now labeled my X as fertilizer. I'm now going to label my Y as height. And this is something you should have done on your own papers. Now, as you guys use this program, you won't need to create all these labels in the program. What you need to be able to do is to type in all the dots over here on the left. When you need to resize your axes so that you can see everything, you come up to the top right and you click the Move Graphics View button. Okay, you're going to click on that one so that when you move your mouse right over the axes, you can click on it, hold it, and as you drag it, then you can change what it's counting by. Okay? Alright, so each of you should now have a graph that looks something like this. Most of them should look fairly similar. However, depending on what you counted by, it might look slightly different. But we should see a similar pattern in all of them. Alright, so let's get back to our presentation. Now, here's where it's coming in for you. What I would suggest, partner up with someone else as you go through this. Have one person pause the video and keep all of this information up. Have the second person open up GeoGebra, and they're going to start graphing each of these. After you guys use GeoGebra to graph it, go ahead and draw it on your paper. Don't spend a huge amount of time drawing it exactly and perfectly. That would take a lot of time. Go ahead and let GeoGebra do a lot of that hard work for you. And then just draw exactly what it looks like onto your paper. You can kind of see, oh, the dots were increasing by about this much each time. This dot took a bigger jump. You should be able to see things like that, but it doesn't have to be super exact. What you should do is label your graph. You need to put the title. Once again, the title is the question. You're going to need to put what does the X represent. Notice for team 2, the X is going to be the depth of the seed. Y is going to be the height of the plant. You're going to need to label those. You should show what the Y was counting by so that we get an approximate idea of the scale. Okay, so right now you should be creating on your own paper, on each individual paper, 4 graphs. You're going to use the computer to help you figure out what it should look like, but each of you should draw each of these 4 graphs on your paper. Alright, begin now. Okay, your graphs should be done by now. All of them should be drawn on your paper. 726, that's our next section. Make sure to write 726. Examine your scatter plot for Team 1 from problem 724. Also look at the scatter plot posters created by your classmates for Teams 2 through 5. Then answer the following questions. For each of the graphs of data, does there appear to be a relationship? So what I'm going to say is Team 1, that's the data that you all graph together on a single sheet of paper. Does there appear to be a relationship? Now, there are 2 ways you can answer. So, if you do think there's a relationship, you're going to answer a bit like this. as something gets larger, then blank gets blank. If you don't think there's a relationship, you're going to answer something like this. There appears to be no relationship between blank and blank. All right, now these are largely going to be the variables of that question. So, to answer these questions, and you're going to need to, for 726, you're going to have an answer for Team 1, for Team 2, for Team 3, for Team 4, for Team 5. And let's examine each of them individually now, looking at the graphs that you should have on your own paper. So here's Team 1. Now, what I do notice from Team 1 is that the more fertilizer they're using, the height is going up, and that would be the sentence that I was put. The more fertilizer, the greater the height. Okay, or to put it the way they have it, as fertilizer gets larger, then the height gets larger. All right, here's Team 2. Does the depth of the seed in each pot affect the plant height? All right, so I notice that as the depth of the planting is going up, so as my x values are going forward, the height of the plant is going down. So, as the depth of the seed gets larger, then the height of the plant gets smaller. And that's what this is telling me. So if I plant it too deep, my seed just isn't going to grow. All right, Team 3. Does the number of seeds in each pot affect the height of the plant? Well, as the number of seeds is going forward, it kind of bounces up and down. And so what I would probably say, because I don't see a clear pattern, there appears to be no relationship between the number of seeds planted and the height. Team 4, does the size of the pot affect the plant height? Alright, so I notice that as the size of the pot gets larger, that's us going forward through these dots. Is it changing the height? Once again, it kind of bounces up and down, but I don't see that there's a clear pattern of whether or not going forward takes us up or down. So, once again, I would say that the size of there appears to be no relationship between the size of the pot and the height. Team 5, does the number of hours of sunlight per day affect the plant height? Okay, well, we can see as sunlight hours go up, so does the height. The more sunlight hours they have, the taller the plant. So, as the number of hours of sunlight gets larger, then the height of the plant gets larger. Okay, make sure you've got an answer for each of those. All right, now 726b. So we're still in 726. We're going to talk about the direction of association. Now, in a scatter plot, if there appears to be no relationship between the variables, then the points on the scatter plot have no association. So you guys will notice in this graph right here, the dots are just kind of scattered. I don't see a clear pattern forming, so I'm saying there's no association. But if one variable generally increases while the other increases, we notice that in this one, the further forward we go, the higher the dots get. So both are increasing together. That's what we call positive association. If one variable decreases as the other increases, so I notice that as I'm going forward here, so as x increases, the y variable seems to be going down. As we go forward, the dots are going down. This is called a negative association. I want you guys to review each of the graphs to identify positive, negative, or no association. So let's quickly take a look at each of those ourselves. So once again, let's start out with Team 1. Team 1, I see going up and going up, so positive association. I see that as I go forward from A, B, C, D, as I'm going forward, the dots seem to be going down. This is a negative association. I don't see they're going up or down. I don't see a clear pattern, so I would say no association. Once again, no association between the size of the pot and how tall the plant is growing. Between hours of sunlight and plant height, positive association. Okay, now the form of association. Now make sure for B you've already written down for Team 1 what type of association, for Team 2 what type of association, for Team 3 what type of association. Now for C we're going to talk about the form of the association, and once again we're going to have Team 1, Team 2, Team 3, Team 4, Team 5. When there is a positive or negative association, the shape of the pattern is called the form of the association. Associations can have a linear form or a nonlinear form. The form can be made up of clusters. So these are some examples below. So when we're talking about linear, we're talking about they all seem to be, the dots seem to be lining up fairly well for us. Now, they're not all going to line up perfectly, but we do see that they are forming up into more or less a line. Now, that dot does cause some confusion, and I want you to keep the look of that one in your head because we're going to look into something about that later. Now, an example of linear is gas mileage and the weight in the truck. So the more weight you have in a truck, the worse your gas mileage is going to be. Okay, so the heavier the truck, the less gas, or the lower your gas mileage is going to be. And that's kind of a linear thing. Now, nonlinear seems to form a curve. The dots start curving on themselves. So this is a negative nonlinear association. Okay, so this could be the temperature of a cup of coffee, how it decreases over time. So maybe initially it was super hot and it starts going down quickly, but it's going to approach room temperature and it's going to stop getting colder. So we see this kind of curves. Now this next one is linear with clusters. So we notice that we've got a pocket of dots here, a pocket of dots here, but not so much in between. So we've kind of got these different groupings. So that's what we're calling linear with clusters. So now let's look back and see what types of things we can see from our graphs. Okay, so here's Team 1. What it's looking like to me is we've got kind of this linear growth. I see a positive linear relationship. Okay, for Team 2, now I can kind of go two ways here. I could believe that there was a bit of a curve here, but I could also believe that that looked more linear. For this one, I think it really depends on your perspective. What did you think? Sometimes figuring out these associations isn't black and white. There's some room for discussion and debate. Okay, now this one, no association. Team 4, we had no association. Okay, and here, I would say that looks pretty linear to me. So the only one that kind of looked like it was non-linear, and even then, maybe we would still call this linear, was Team 2's data, which I could kind of see having a bit of a curve to it. So that was for C. Make sure you've written down the type of association. Was it linear? Was it non-linear? If there was no relationship, then we would also just call that non-linear. Okay, outliers. Now, an outlier is a piece of data that does not seem to fit in the pattern. Do there appear to be any outliers in any of the example scatter plots from before? So we would look back at some of the things that we had before, and I kind of already told you guys to look at this first scatter plot here. We did seem to have a nice line forming right here, but this one dot just kind of outside of what the rest of the dots are doing. That is what we call an outlier. Okay, so we've done a lot of talking. We've written down a lot of things about what the graph is showing, about the relationship between our two variables. The very first thing we did in this problem is we created hypotheses. Go back to your answers in A. Check to see if your predictions were correct or incorrect, and explain why you think you were either right or wrong. So there's two parts of that. Now, you're also going to have 5 answers for each one. Team 1, was your hypothesis correct or incorrect? Team 2, was your hypothesis correct or incorrect? Team 3, was your hypothesis correct or incorrect? And so on and so on. Okay. 727, write it at the top of your paper. When there is an association, predictions can be made. One way to help make a prediction is to draw a line or curve. You guys have kind of seen me do that today, or best fit for the data. Find your graph of Team 1's data. This should be the paper you did as a team, that one graph that you all did together. Work with your team to draw a straight line that represents the trend of the data on this graph. This line does not need to intersect each of the points. That's important. You don't have to go through all of the dots. And the line does not need to pass through the origin. It doesn't have to start at 0, 0. Okay, what you're trying to do is draw a line that looks like it's following the pattern of the dots. So on that paper right now, draw your line. It should be a straight line, no curving. Now, use your line of best fit to predict the height of the plant when 12 millimeters of fertilizer are given to the plant over a 3-week period. All right, so let's see. Now, I'm going to kind of walk through doing this with my data. However, me doing this with my data should not necessarily be exactly the same as yours. So I'm going to draw my line. Alright, so there's my line. Now, it wanted us to predict for 12. So I'm going to look at my line and see kind of what value am I getting at 12. And I see that if we put about 12 millimeters of fertilizer in, that we'd expect it to be about 21 centimeters tall. So that's what we would predict for that amount of fertilizer. Now, depending on the line you drew, your graph, maybe your graph was much larger than mine, maybe smaller, maybe your answer is going to be far more accurate than the one that I just gave. This is just my prediction. But hopefully you should follow a very similar step. Okay, now what is the y-intercept? And interpret the y-intercept of this situation. So let's go back to that. So I'm going to draw my line again. So there's my line. Now the y-intercept is where we are crossing the y-axis. So it looks to me like I'm between 5 and 10. Looks like halfway in between. So I'm going to say my y-intercept is a 7. That's my y-intercept. So now we need to talk about what does the y-intercept mean. So my y-intercept, you'll notice that it's happening where x is a 0. So in other words, when there's no fertilizer, so with 0 fertilizer, I would expect this plant to grow to about 7 centimeters. And that's what my y-intercept is telling me, is that even without fertilizer, I expect this plant to grow to about 7 centimeters. Okay, you've now finished this video. Make sure to have everything written down, your work all written down. If class is not over yet, please use the remainder of the time to quietly be productive and working. If you're not sure what to work on, Success Maker is always there for you.